Hey folks, thanks for joining me today and going with me through this presentation. I'll try to keep it short and concise, but give you the amount of information that makes sense. So today we're going to be talking a little bit about unleashing GitOps, but without the usual developer headache or complexity. Before we jump into the presentation itself, and I promise not to bore you to death with the slides, at least I'll try, and we will jump into them very soon. But before we go into that, a little bit about me. I'm Bruno Andrade, one of the founders here at Shipa, where we focus on creating an application layer that you can use to standardize how you deploy, manage, and secure applications across different infrastructure providers, GKE, AKS, and so on, using different CI/CD pipelines and GitOps pipelines. So as a background, I'm a former software developer or engineer who later turned into sysadmin. So prior to having those fancy names that you have today, or that most of us have today, such as DevOps, DevSecOps, SREs, and all these things, at the time we were all sysadmins. That's where I come from. I love pizza and music. I say that my original goal was to be a musician. Right now, you don't have a background, but when I don't have a background, you can see guitars and all that stuff. But I realized that I was not good enough to make a living out of it, so I went into software engineering. I realized I was not good enough for that as well, but too late. And I don't really like complicated things, and that's one of the reasons why I decided to start with Shipa, and I'm part of the Catch project and so on. We already have too many things in our lives, right? So a little bit of a background on the GitOps and developer space, right? As a DevOps or sysadmin or platform engineer, we spend months and sometimes more than a year building our infrastructure, right? If you think about putting together all the Kubernetes clusters, automation using Terraform or Pulumi, and now we're implementing GitOps with Argo CD and changing and building all these things. It's complex. It takes time and it's challenging to put this all together. And this is the common response that many times we get from our developer. They hate it, right? And there's a reason behind it. Having the opportunity to talk to so many developers about how they see Kubernetes and how they see GitOps, despite it being interesting as a technology, when you talk to them about the evolution to GitOps, they paint this picture that, hey, we've gone through VMs where the DevOps team gave all the automation on how we deploy our applications using shell script at the time, right? And then we changed to things like Ansible, right? And then we had to change again how we deploy our applications, and then came in Docker, and then later on came Terraform, and then Kubernetes. And each change introduced basically changed how we deploy and manage our applications. And the reason why this happened is because applications today are fundamentally tied to the underlying infrastructure. So when you deploy using Argo or when you deploy using Terraform, you are not defining really an application, but you're defining the underlying today, Kubernetes objects, manifests, and so on, right? And if you think about it, for many times us as DevOps, we spend a lot of time trying to learn the infrastructure components, putting together. So for us, it's not complicated. And many times we put that in the hands of the developer, right? Saying, you can do it. If you think about the kind of software development lifecycle, they just have to go through kind of build, test, deploy, and manage their applications. What's the complexity? And basically, this is what you and we have across most organizations that we work. Right? The stack is complex. It's complex for us as DevOps, managing our clusters and bringing evolution to our infrastructure and changes and GitOps and all that cool stuff. But it's also complex for the developer. And if you focus primarily in the deploy and run or deploy and manage aspect, every time there is a change there, either you're moving from 119 to 120, 121 clusters, or from GKE to AKS, it introduces changes. And if you're moving from Terraform to Pulumi or from Terraform to GitOps, it changes all over again, right? So infrastructure is becoming very fragmented. And that fragmentation brings a lot of challenges for us, the DevOps, as well as for the developers. And bringing GitOps into the picture now is another challenge that we're introducing as change. There are the clear benefits, and that's not the purpose of the call today, on discussing is GitOps a good approach or not, but it introduces changes and introduces challenges. So what if we could split the deploy and run, or deploy and manage phases, right? Again, if you use Terraform to deploy on Kubernetes 119 on premises, you may need to template specifically for that. Tomorrow, if you move to GKE 120, a lot of your templates, you're going to need to redo it. So it's a lot of effort on us as DevOps, and it's a lot of effort on the developer side to basically readapt and relearn all these things. And as we keep moving the stack, and our infrastructure as code stack has changed from Terraform to GitOps, now Argo CD, for example, which is the topic of this talk, it changes all over again. And as Kubernetes changes the APIs, basically our templates have to change. And if you're starting, if you have just a few services, you may get around. You can template with Helm, for example. You have just a few services to deploy, that's fine. But as you start deploying across different clusters, and you have different development teams, and you have different applications and requirements, then it starts to get super tricky, right? And you want to be able to keep on evolving your infrastructure, but without having to deal with a lot of that complexity, and without having to have the developers depend on you every time to manage those templates, help them troubleshoot their applications, and get their applications up and running, right? So if we think about it as kind of separating those two steps, and in the middle, we actually bring in an application layer, and that can actually implement a standard way that you can define and deploy your applications. No matter if you're using Terraform, or if you're using Argo CD in this case. And no matter if you're using on-premises Kubernetes, Rancher Kubernetes, or if you're using GKE 120, for example, the definition of the application is still the same. That would allow you then to actually break apart and detach the application from the underlying infrastructure. And when you do that, you can keep on evolving cluster. Let's say tomorrow you want to bring up a new cluster with version 121, for example, or you want to create a new cluster in a new cloud provider, or you want to create a new cluster using Rancher, for example, and others. You can do that because your templates and your application definition is not tied to that. And the same way on the other side, on your pipeline and your delivery and infrastructure as code. If you have projects where developers, they want to use Terraform, that's fine. You can give them that standard definition. But as you start introducing GitOps in the organization, if you keep that same application definition, that's where you're going to make the developer's life easier. And that's where you are going to be able to actually evolve your infrastructure a lot faster, right? Because the experience is the same. So now you're choosing the tools, but keeping the same experience, so it doesn't impact you anymore, and doesn't impact the development team as well. So you're basically moving away from this thing, right? Where your developer is basically going, what the hell is happening here? I know, lame joke. But they're going away from this, right? Again, as a DevOps engineer, this might be easy for you, because that's where you spend most of your time, understanding infrastructure, understanding complex components and how they come together. But developers are focused on the application, and that's fair. I don't spend my weekends reading Java books so I can troubleshoot Java code when there's a problem with the application. I mean, to each its own, right? So you're moving your developer away from having to understand all of this, and you're moving yourself from having to create and manage all of these components and changing them all every time there is a change, to basically something like this, where it's easy and focus on the application. I'm not focusing here in this definition. It's a super simple definition, of course, and you can extend and add some more things, but you're focusing again on the application. This definition deploys exactly the same that actually this Helm chart deploys, but this is focused on the application, and it leverages Catch on the background. So Catch puts together all the components that Kubernetes needs to run that application, service, ingress, and all that together, and we're gonna show on a demo pretty soon. And as mentioned, if you're using something like Catch, and you're using Pulumi, for example, and you want to use Crossplane as infrastructure as code, you can see that the application definition, it's exactly the same. I mean, other than the boilerplate that YAML or JavaScript introduces, for example, application definition is the same. Your developer doesn't need to know if you're running GKE, if it's Helm, if it's customized. They can pick the tool, or you can pick the tool that makes sense for you to help that developer or help those applications get deployed, right? So we're gonna jump into the demo. But before we jump into the demo, just a quick highlight of what we're gonna be using. This is me on my left side. I think I can kind of move myself out of here. There you go. So that's me, but actually that picture here, it's probably from 5 years ago when I actually had more hair. Today is not going too well, but this is me. And I'm pushing my code to Git. I'm keeping true to the GitOps principles. We're gonna be using Argo. Argo is right there, somewhere, exactly. And we're gonna be using Catch. Catch is an open source project, and when we're done with the demo, I'll show you exactly the Git repo, but you can find Catch open source Git repo. You can clone. Would love to see some support and some stars, and feel free to open up issues and help us develop the product and so on. But we're going to be using Argo CD as the GitOps engine. We're going to be using Catch with Crossplane, and we're going to be delivering to a GKE cluster, I think. And we're going to be delivering an application or applications across multiple namespaces. So it's all open source stack. You can get started for free. So let's see what it looks like. All right, so now if I check on my terminal, I can see that I already have my GKE cluster available and running, and my kubectl, kubectl, kubecontrol, whatever you want to call it, whatever makes you happy, it is already configured, and I can access that cluster. If I do get namespace, for example, I can see I already have a few things installed. So I already have Argo installed. I have Istio installed. I have Crossplane installed. And I have Catch installed. So basically, I have the components that we listed on the deck before, right? Crossplane, Catch with and Argo CD, right? And I'm using Istio here because that's the ingress controller that I had installed. Awesome. So now, if I go here, I have a simple repo that we're going to be using today. And in that simple repo, you can see that I've broken it down into two different folders, one for apps and another one for namespaces. Regarding Catch, right? Catch is already installed in my cluster, but if you need to get started with Catch, you don't have it installed in your cluster yet, you can go to learn.thecatch.io. Again, learn.thecatch.io. You can see a getting started part here. It's super simple. You can install the Catch CLI, install a cert manager, and you can choose the ingress controller, for example, that you want to use, or Traffic or Istio. I chose Istio for my example because that's what most people use these days. I install a cluster issuer and the Catch controller. Super easy, and it's straightforward to install. Now, Catch interacts for our example, Catch is interacting with Crossplane. Catch has a Crossplane plugin, and you can find information as well as on learn.thecatch.io. You can find information here on how to install both Crossplane. Installing Crossplane is quite easy, and installing the Catch provider for us to run this example. Great, so we know how to install Catch. We know where to find information to install Crossplane and the Catch provider for Crossplane, and installing Argo is super easy. So let's go into the namespace definitions and the application definitions. So we see what actually looks like, right? If we go first to our namespaces, I have two here, dev and production. Catch calls namespaces frameworks. A little bit of background, Catch is an open source project that was created by Shipa. So Shippa uses Catch internally to deploy the applications. So Catch is the application layer or the deployment engine that Shippa uses to create that application layer. And Shippa calls it framework. So Catch also carry that for now at least. So when you think framework, just associate namespace. So when we create a framework, we're creating a namespace. So here, what we're doing is we're saying, hey, the kind is framework, and this is the name of the framework or the name of the namespace that Catch should create. And one additional point that we're passing here is the service endpoint. So is the service endpoint used by Istio or created by Istio, right? Why are we passing that here? It's because every time Catch deploys an application to this namespace / framework, Catch will automatically create an endpoint where your application is going to be exposed so developers can access the application, right? So they don't need to go through like, how do I create a service? How do I expose apps and all that stuff? So when you're creating namespaces, you pass the service endpoint so Catch can create the endpoint for the apps automatically. And if you have Istio, you can pass the Istio endpoint here, or if it's traffic, for example, we can pass it here. So I'm creating two namespaces, right? Dev and production. They're basically the same other than the name. If I come in here, I have the Catch CLI installed in my terminal. If I do framework list, there's nothing. So there's no namespace associated to that. Let's go to Argo now. If we do new app, for example, and we call it namespaces, for example, we can call it project default. We can do this. We're gonna keep the repo URL. I already have it configured. And the path now is gonna be this. At this point, you're saying, why is this guy not using a definition file to do this instead of the UI? I like the UI. So namespaces, and then cluster URL, it's in cluster because I'm deploying in the same cluster. Great. I'm not gonna do anything fancy. I'm just gonna tell Argo to go back to Git, get the namespace definitions, and create it using Catch and Crossplane. I'll do create, I'll click on create. All right, so it says it's synced and it created. So if I go back in here and I say Catch framework list, I see the two frameworks created. And if I do get namespace, I can see that the namespaces, they were created. Catch dev framework, Catch prod framework. If you want, you can tell Catch to, instead of create a new namespace for the framework, use an existing namespace. You can also do that. In our example, I'm just telling Catch, just create everything. So I can keep the namespace definitions in Git. Awesome. So now if I go to my app folder, right? I have two applications in here. I have dev app 1 and dev production 1 apps. If I go into this definition, I have here the provider and it's a type app. And the only thing I'm passing as a developer, and you can break it down, right? The namespace repo can be owned or should be owned by the DevOps team if you want. And the application repo can be owned by the developers, or you can put it all together, go nuts, do everything you want, as long as it's in Git. So here you can find the application name, the application image, which is a bulletin board, and the name of the framework, or the name of the namespace where I want this application to be deployed to. Easy, right? Developers can get around with this. And if I look at the production app 1, I see the same thing. I'm deploying an application called pod info in this case. Here I have a little bit more. So I'm saying, yeah, this is the framework or namespace that I want it to be deployed. But here's the port or ports that I want to expose when this application is deployed. And here is the number of units that it should have by default. you can find more information around application definition options, for example, directly from here, where you can expose ports, units, processes, route settings, and all that stuff, as well as from a framework management if you're deploying or if you're deploying jobs, for example. So you can find further definitions in the documentation, learn.thecatch.io. But here in our example, I have those two things. One application basic bulletin board, just get it deployed. Second one, pod info, deploying this app, but exposes on port 9898 and deploys with the different units, right? So let's go back to Argo. I'll create a new app here. I'll call it apps. Default project, automatic, do all this, but now my path is going to be apps. It's in cluster, same thing. I'll just do create. Created. Oh my God, let's go back and see. If we do catch app list, for example, I see the applications running and the applications already available. Duh. If I click on open application, the right link, then I can see the application opens up. If I click on the second one, I can see my pod info application deployed as well. So now as a developer, I can finally understand the application definition in an easy way, right? And I can get my applications deployed. I can use Argo, I can use Kubernetes. And if tomorrow I want to move from Argo and maybe not move, but use on some projects, use Pulumi, for example, you can see it's exactly the same definition. So now you're free to detach the application from the infrastructure, use and experiment with different infrastructure as code, GitOps, different pipelines, and you can bind catch to any pipeline you have and help you deliver applications to Kubernetes with a good developer experience. So let's just go back to the last slide. All right, so just to close, I really appreciate you taking the time to go through this. I hope that was useful. As mentioned, Catch is an open source project, and you can find it under github.com/shipa-corp/catch. I'd love your support. I'd love to see what you think about it and how we can evolve Catch. We have tons planned. We're gonna be creating plugins where you can easily extend Catch if you want to add other ingress controllers or add storage or other application definition components. You can find Catch docs on learn.thecatch.io, and the simple repo that I use, it's here. It's super simple, and the definitions that we used is in the documentation as well. So we would love to see your support. Help us build Catch. Help us build an application definition layer that you can use anywhere, that will allow you as a DevOps to evolve the infrastructure without all the complexity and having to rebuild charts and rebuild everything every time you change API version or cluster version or you change infrastructure as code provider. So help us standardize this. We'd love to hear your thoughts and your use cases and build together with you. I appreciate you taking the time. Thank you.